All right, so I wanted to give you one more example with concavity. All right, so the third function that I did in the video for increasing and decreasing was this one, f of x equals 3x to the 2/3 minus x. All right, so the other video I posted was on increasing, decreasing for this function, and now we'll do concavity. All right, so I'm gonna find the second derivative, which means I have to find the first derivative again. So bring down the 2/3, x, 2/3 minus 1 will give us negative 1/3, and then derivative of x was 1. So just kind of cleaning that up a little bit. 2x to the negative 1/3 minus 1. And then second derivative, the 2 goes along for the ride, bring down the negative 1/3, x to the negative 1/3 minus 1. Again, negative 1/3 minus 1. Get common denominator over here, you get negative 4/3. And then derivative of negative 1 is just going to be 0. So I can write this as negative 2/3 x to the negative 4/3, or negative 2 over 3x to the positive 4/3. All right. So now that fraction is never going to be equal to 0, but it is undefined when x is equal to 0. Okay, if I try to plug in 0 there, I'm going to get something undefined. So just like with critical points for your sign chart for the second derivative, any place that that second derivative is 0 or undefined is a place where it might possibly change concavity. All right, so that's going to be my only point that could be a possible inflection point. And we're going to put second derivative information up top and concavity information down below. So I pick any number to the left of 0. Negative 1 is nice. Anything to the right of 0, positive 1 is nice. And we're going to plug into my second derivative. So I'm definitely going to use this nice one that I simplified. F double prime of negative 1. Okay, now I want to think about what that 4/3 fraction is equal to. So that's the cube root of negative 1 raised to the 4th. Remember, that's what those fractional exponents mean. The denominator tells you what kind of root, and the numerator tells you what the exponent is. So negative 1 to the 4th is a positive 1. So this is the cube root of positive 1. So this is actually equal to negative 2/3, or a negative number. Okay, so for my sign chart, negative, and that means that the function to the left of 0 is concave down. All right, and then I'm going to do the same thing with 1. I'm going to find f double prime of 1. Okay, so I'm going to plug into my second derivative, negative 2, 3 times 1 to the 4/3. And again, I'm going to think of the cube root of 1 to the 4th. All right, so this also gives me a negative 2/3. Okay, so the second derivative is negative there as well. So the original function is concave down. All right, so when I'm going to go write my intervals of concavity, f of x is always concave down. From negative infinity to 0, and then again from 0 to infinity. Okay, so we always skip those points that are marked on the number line, either for increasing, decreasing, or concave up, concave down. So I skip 0, and the reason is that the function is not actually concave down or concave up at that point. If I were to hop over to Desmos, and you may want to do that for this one, I can't do that from this video app I'm using right now, but the graph kind of, let's see, yeah, the graph kind of looks like a bird, and then it kind of has that maximum point and starts going down there. Okay, so you can kind of see that the graph is always concave down like a frown the whole time, but it doesn't make sense to say at x equals 0, that's the little bird point. It doesn't make sense to say that it has any concavity there because it's just kind of that cusp point on the graph. All right, and also because the function didn't change concavity, it was concave down and then concave down, 0 is not an inflection point. So we would say that f of x has no inflection points. Okay, so for the first derivative, we would say it's a critical point if it's equal to 0 or undefined, if the first derivative is equal to 0 or undefined. For the second derivative, we only say it's an inflection point if the function actually changes concavity there. Okay, so this function has no inflection points. All right, and that's it for concavity. See you on Friday.